As can be seen, the straightening of the crimped ligament fibrils occurs in region AB in the load elongation curve shown below. This is due to the fact that at the most basic level, tendons are made up of tropocollagen molecules. Groups of tropocollagen molecules come together to form ligament fibrils, and bundles of these fibrils come together in a crimped waveform pattern to form fibrae. Bundles of these fibrae, along with tenocytes, make up fascicles, which in turn group together to form tendons. As a load is applied to the tendon, the crimped waveform pattern of the fibrils straightens out without much resistance in a similar fashion to this crimped piece of paper. Following this, much more force is needed to further stretch the tendon. As shown here, the linear relationship between an applied stress and the resultant deformation in the region depicted below defines a material's modulus of elasticity. Stress, shown in the top graph as load, is defined as the force exerted per area on an object. The elongation that results from this applied stress can be restated as strain, which is defined as the change in length divided by the initial length. Using these definitions, we can rewrite the load versus elongation curve as a stress versus strain curve as is shown in the graph below. The elastic region of deformation is defined as the area of the curve where the material will return to its original shape once the applied force is removed. There is usually a linear relationship between stress and strain in this region, and the slope of this linear relationship is called the modulus of elasticity. An example of this elastic deformation is shown here using a rubber band. The other answer choices for this question are incorrect because of the following reasons. Brittleness is not correct because it is a way to classify materials. Brittle materials such as glass are usually hard and fracture without substantially deforming. Yield strength is not correct because it is the point at which a material transitions from elastic or reversible deformation to plastic or irreversible deformation. Ultimate strength is not correct because this is the maximum load that a material is able to withstand. And finally, toughness is not correct because this is a measure of how much energy a material can absorb before fracturing and can be found by finding the area underneath the load versus elongation curve.